Hello everyone, welcome to the channel. Here's a real GCSE Physics style question on energy. It's about a roller coaster and how energy transfers as it moves. Pause the video, give it a go yourself, and then check your answer against mine. Let's see how many marks you can get. So we know the mass of this car is 500 kg. It's pulled to the top of a track 20 meters above the ground. Okay, so the height is 20 meters. It is then released and rolls down the track. Calculate the gravitational potential energy gained by the roller coaster car at the top of the track. Now, this is very easy. The formula is gravitational potential energy is equal to mgh. So, m is 500, g in GCSEs, consider this as 10. If you took as 9.8, that's still okay. Times by height is 20 meters. So the answer is 100,000 joules. Part B. At the bottom of the track, here, most of the GPE has been transferred into kinetic energy. Explain why the car does not gain all of the gravitational potential energy as kinetic energy. Now in practice, all of its GPE is not converted to kinetic energy. Now the reason is some energy is transferred to the surroundings as heat, because when it's moving on a track. There is friction, and also it's moving through air, so there is air resistance. So it has to do some work against those forces. So here's how you can word it to get 2 marks. Part C. State one way energy is wasted in this system and how this affects the total energy available for useful work. Now we kind of discussed already this in part B. Energy is wasted as thermal energy because of the friction between the wheels and the track. Now, what that means is, out of this 100,000 joules of energy that this has at the beginning, say it's 100,000 joules, and because of the friction and air resistance and all that in this path, let's say, for example, it uses 20,000 joules. What that means is, the amount of kinetic energy available at that point will be 100,000, take away 20,000, because remember, energy is conserved. So the total amount of energy should be the same. So we had 100,000, 20,000 joules of that was used to do work against friction and all that. So the amount of kinetic energy available here, maximum, now will be 80,000 joules. So state one way, we can talk about it in the system and how this affects the total energy available for useful work. So here's the answer for part C.